Okay, here's our practice test. Question number 1, we're going to use this relationship. The velocity is equal to the frequency times the wavelength, where the velocity for speed of sound is 343 meters per second. The question tells us that he sings with a frequency of 200 hertz. So from that we can find wavelength by dividing. Oops, dang it. Okay, 1.715 meters. So that's the wavelength of this wave. And you need to sort of look at the diagram and determine the relationship between the wavelength and the width of the shower. So the shower is this wide. I'm hoping it's obvious that that is half of the wavelength. So we could say that the length of the shower
Jewel, please come to the front office. Jewel.
half the wavelength. Hey. And if the wavelength is 1.715, then we have that the length of the shower is 1/2 of 1.715, which is 0.86 meters, or 86 centimeters, which is sort of standard for a shower. Okay. 2, how many times faster than sound does light travel? So let's take a look at these numbers. You should know this. Speed of light is 3 times 10 to the 8th meters per second, and speed of sound is 343 meters per second. So if we were to divide those like this, we would get 3 times 10 to the 8th divided by 343. Oh my. 8.7 times 10 to the 5th. Times 10 to the 5th times as fast. So that's 874,000 times as fast. So a whole lot faster. 3, as white light passes into then out of a raindrop, color separation occurs because blue light bends more than red light. What does this tell us about the speeds they travel through water? So blue would be a little bit slower because it bends more, and red would be a little bit faster because it bends less. If you're looking at a rainbow, where will the sun be? And this is behind you. And I don't really have space to redraw that diagram, but you should have a diagram in your notes where it sort of shows the person and the sun and the raindrops and the sky that end up refracting and reflecting light back to the person. 5, describe the rule about counting. So here's thunder and lightning. So when you hear the boom, well, first you're going to see the flash, and that is the lightning, and then you're going to hear the boom. And the boom is basically the sound of the spark. Okay, the flash gets to us really fast, 3 times 10 to the 8th meters per second. And the boom is sound, so it gets to us at 343 meters per second. So it turns out that this is essentially instantaneous, and this takes a little while. It takes about 5 seconds per mile. So the rule is you count, and every 5 seconds means the lightning was 1 mile away. A car blaring the horn approaches, then passes you. You would hear the Doppler effect. When this occurs, the wavelength of the sound waves in front of the approaching car would be shorter relative to the wavelength of the sound waves behind the car after it passes you. We drew this little diagram like so. So wavelengths longer behind, wavelengths shorter in front. 7, this question's a little vague. When a light wave passes from glass into air, it will bend, and it will bend towards the normal. Let's see, from glass into air, that is wrong. It will bend away from the normal. Away from the normal. Normal means perpendicular. I'm going to abbreviate perp. But from glass into air, so it would be like